Hi guys, Nick here again with Lime Tree Laser Co. and How TN Lasers. We're doing another video today. This is going to be a bit more of a beginner video on using your 3D UV Feeltek laser. We're going to start by doing a simple flat engraving on a painted aluminum card. We'll do another simple engraving on a 1.5" wooden dowel. This is hemlock. And then since everybody buys the UVs for glass, we'll finish it up by doing an engraving on this 10.5 ounce rocks glass. Now, using a 3D Feeltek laser, it's not hard by any means, but there are some very critical steps and concepts that you do need to understand to be successful with it. So we'll address a few of the common pitfalls that Mark sees quite often, and a few of the small errors that can happen. That being said, everything with these lasers relies on having a very well calibrated machine. So do make sure that you've done all of the calibration steps that you need to be doing, and that everything's square, and that your 3D calibration is done. There's a few videos out there now that show that process. So if this is the first engravings that you're doing with your brand new machine, do make sure you calibrated it first, because the UVs, lasers especially, they can be tricky. So I hope you enjoy, follow along, and let's get started. So before we head over to the lasers, there's something I'd like to really quickly explain to you. Now, you'll have to forgive me, we're doing this the old-fashioned way. I don't use a tablet on this PC, so we're going to use a pen and paper. And basically, I just wanted to quickly explain focal depth to you guys, so that when the meaning can get a little conflated sometimes, so I just want to make sure we're all on the same page. If we think of a laser beam running through an optical lens, I think most people understand that we'll start to see a bit of a shape like that of where our laser is in focus versus where it is out of focus. This distance is what we call focal depth. Now, on a CO2 or a fiber laser, a non-3D, depending on your lens, this focal depth can be quite large, actually. One thing that we need to take into account is that with a UV laser, we have a very, very small focal depth. Now, with that small focal depth, we get an incredibly great level of detail, but we do need to remember that it is very easy to get out of focus with a UV laser. On some materials, it doesn't make that much of a difference. On glass, this is critical, that we have a very small focal depth, and we need to do absolutely everything we can to ensure that we're marking in the correct location. So that's just something I really wanted to quickly explain. I think most people do understand this, but hey, you never know. Some people might be buying a UV as their first laser, so this is something important to remember. We'll talk about it a bit more as we get to the laser, but just remember, when I say focal depth, this is the distance we're talking about here. Okay, guys. Hi, welcome to the video again. Let's get started here. We're going to start with something very simple. We're going to do the aluminum painted card that you may have received some with your laser. If not, they're all over Amazon. They're very easy to find. And it's a great way to really dive in and get your feet wet. So first thing we're going to do here is you'll notice that we're working in our 200 by 200 millimeter workspace. We're going to do that for all three of these objects. So this entire video is going to be ran on our 200 by 200. Now that gives us a 120 millimeter working depth. So that's how much Z height we have to work with. We'll be doing everything at 0. So that is, we don't really need to worry about working depth at the moment. We'll get into that. So let's get started. First thing we're going to do is import a graphic here. And we've got a nice HowTN logo right here ready to go. We're going to resize it first. Let's just do 50 millimeters by 57. That ought to work just fine. Anytime you're working in this software and you see an apply button, always hit that to double check on things. Next thing we need to do is set our hatch parameters. I don't want an outline. I'm going to use the optimized hatch with all of the optimization features. I'm going to leave the angle at 0 and we'll set a distance of 0.01 millimeters and hit apply. You may notice that I did not have to do the break apart procedure. I use Illustrator and JI3 exports, so typically I don't have to. If you try to hatch a graphic and it's looking all funny, it's a simple fix. Highlight it all, go up here to your ungroup button and ungroup it, everything down, highlight again, and hit combine. And then you can hatch it again. There we go. Now I'm going to quickly set my parameters here also, and then we'll talk a little bit about how to set it up properly. With this I'm going to do a 2000 millimeters per second at a frequency of 60 and a pulse width of 95. I run my laser with an inverted pulse width right here. And I do that so that 100 is full power and 0 is no power. I think a lot of people don't use the inverted, so your numbers will likely be different. I just prefer it this way. It just is easier for my smooth brain to figure out. Okay, now, on almost any other piece of software not using a 3D laser, you would think right now you're essentially ready to go. We are not. Because we're using a 3D laser, if we start to rotate around, we can actually start to see that 120 millimeter working depth that I was talking about before. Now, the way these lasers work is we always want to start at the top and work down. It's technically you can do it from the bottom up. I find it can get a little confusing. And focusing, in my opinion, is a lot easier doing it this way. So what we need to do is move our graphic all the way up to the top of our box, which we know is 120 millimeters. So let's go to our properties, into general, and we'll set our Z height at 120 and hit apply. And now you can see we are right at the top there. So now when we go to focus and we use the focus distance that's written on the side of the laser head, we can focus directly down to that highest point, which on a card they're really, the highest point and the lowest point are the same, but this is something that you need to remember when we start getting into the 3D stuff, which we'll be doing right after this one. So we're good to go. We've got our parameters set. We've got our hatch set. We've moved the graphic in its Z height all the way up to 120 millimeters. So let's head over to the laser and focus it and run this engraving. Okay, we're at the laser. We have our card ready to go. First thing we need to do is focus our lens to the card. I use these focus sticks that I've made. I've got a few different styles. With this card you can measure. Why don't we show that? You will want to make yourself some focal sticks, because at least here we can move the card off to the side and we can measure up to our mark on the bottom of the head. When you're using a 3D object or a glass that's going to be directly under the lens, it gets really difficult to use a measuring stick, so you'll want to be making a focal stick for that. We can reference our chart here for our measurement height, and our 200 by 200 workspace requires a 234 millimeter distance. I'm just going to move it to the front so I can see it a little better. $234, there we go. Now you can see we have our outline. It's a little difficult to see on this black card. These gels can help quite a bit. I'll have to give Dean a big thank you for sending me this. It's I believe it's a photography flash gel, but they work great. We're ready to go. I use a wireless mouse here with shortcuts set on these buttons here. I believe it's F1 and F2 to preview and fire. So here we go, let's fire it. Here we go. Pretty simple. Not hard to do, like I said. Things do get a little trickier when we start moving into 3D objects. So why don't we do that? Congratulations, you've done your first engraving. Let's move on to the real fun stuff. Okay, moving on. Next thing we're going to do is do a mark on this 1.5 inch diameter piece of hemlock dowel. Again, wood isn't quite as focal dependent as glass, so we've got a little bit of leeway. But what I'd like to show you here is that I'm going to be using this same jig setup for glass. So you'll see that I've got an XY table here. I've ran a center line down it as well. You probably can't see them, but I do have center marks on the acrylic line here. And I simply just projected a straight line and line mark to line everything up with that. We'll talk a little bit more about why that is so important with glass. Wood, it's not quite as detrimental, but it's a good practice to always make sure everything is as centered as possible when you're working with a 3D laser. And in particular glass. Like I said, we talked about that focal depth a little bit earlier. And with glass, that focal depth is extremely important. So again, same thing we did before. We're going to focus the very top edge of our object to the lens. And this is where I say to use some kind of a focal stick. Again, I guess with this object, we can really pull it down a little bit and measure from there. Now, if this was not nearly this long and we needed it there, we can't really measure from there. So let's upgrade to our focal stick. Let's use that from the rest of this video. Move the head up. And focus to that top edge. There we go. Now, I typically like to set my object in its place and get it ready to go before I move into the software. And the reason for that is that you get a little bit better of an idea of your framing and everything. You want to make sure everything's in focus. And it's very easy to hop over into the software, get everything set, start framing, and then things don't look right. And the reason for that is that you're not focused yet, and sizes will change when they're out of focus. So getting your object down, aligned, and focused first is just a good way to make sure that you don't skip a step later on. So that's ready to go. Let's move back to the laser. Sorry, back to the computer. Okay, here we are back in Landmark. I've just started a new document and just imported that same graphic. So let's get started again. First thing we need to do now is create a model to engrave on. We're using a cylinder, so we'll start with that. We're going to need a calculator because we're working in millimeters. So a simple cylinder. Now I said before that this was 1.5 inches. So let's get that into millimeters. That's 38.1. We'll divide that by 2 to get our radius, 19.05. For this particular object, our height doesn't really matter much. And I'll do a start at 0 and end at 180, so we only have half of a cylinder. There we are. That is our model that we will be projecting this graphic onto. Now same thing, we need to move this up to the top of our working height, and we're going to have to put a little math into this one. Let's select it first. We can bring up our move window. So we know our radius is 19.05. So let's just take 120, subtract 19.05. That gives us 100.95. That is the height we need to move this up to get it to the top. So we'll add that into our Z column. We'll click the relative position and hit OK. Now we can choose a side view just to quickly verify that we did our math correct. The top of our cylinder is at the top of our working field. So we know that's good. Let's go back to our top view. We're going to select our graphic and bring it back down to the origin, which is 0x, 0y. Now for placement, I usually like to bring it up to 120 so we can see it on top of our object. Obviously this is a little bit big, so why don't we move that down? Let's do, say, 75% of diameter. So we have a 1.5 inch cylinder. We'll turn that into millimeters by multiplying by 25.4. So that gives us 38.1 as a diameter. And let's multiply that by 0.75. So that's a 75% of diameter, which is a pretty common target for most cylinder engravings. 28.575. So we'll resize this proportionally by that 28.575 and hit apply. That's looking pretty good. Next thing we need to do is we need to hatch this. Again, I don't want an outline. I'm going to do a bidirectional hatch on this one. I find it works much better for wood. Again, all of the options selected, but this time we're going to do a 0.07 millimeter line distance. And there's a few schools of thought on this when doing 3D engraving. Some people like to do a 90-degree hatch, which would be this direction, so that the focusing lens, when you'll essentially be engraving the entire thing left to right, and the focus lens doesn't have to do as much work. It only really has to move in, then out, then back in. If you're doing a 0 degree where you're moving, say, from bottom to top, your focusing lens on the head is going to be focusing in, out, in on every single path. Pass. Now, that being said, I'm going to do a 45 degree. And I'll tell you why. It's because with wood, I like to go very slow. We've got a pretty big line distance on our hatch, so I'm going to go right down to 100 millimeters per second. And that gives it a lot of time for that focusing lens to do what it needs to do. I will quickly set 65 hertz frequency, and again we'll run this at 90%, and again inverted pulse width, so we're on the higher end of power. We'll hit apply. Now, this is one of the common problems Mark has been seeing when we're projecting a graphic onto a cylinder. It's a little different when you're using these tools. You can actually project from that 120 height. When using imported models, you always have to have the graphic down at 0. And to be honest, whenever I'm doing a projection onto a 3D object, I always just start at 0 anyways. You can still use the wrap feature, or you can also use the straight projection, which will essentially, again, it's kind of hard to see. The difference is that this projection mode essentially projects it straight down. So you'll see that, again, it's kind of tough to see, but you can see that this is starting to stretch out from our original width up here. Whereas if we do the actual wrap, it's the same size. So essentially what it's doing is it's taking the graphic, and you can think of it as just shooting it straight down. So if you're looking at this object with your eye from this space, you will see that exact shape. So I'm sure a lot of you know that when we're doing circular objects on a wrap on a cylinder, we start to get that egg shape. So we correct that by stretching our circle out into an oval, so that when we engrave it, we actually have a circle when you're looking at it. This straight projection mode is essentially just doing that for us. And if you're using an imported model, you'll have to use that mode anyways. So I use it most of the time. Sometimes I don't. It really depends on what I'm doing. So again, let's take a quick inventory. We've set our burn parameters of the Feeltek logo here. We've projected it onto our cylinder. You can see it wrapping around. And we're also at the very top of our 120 mil working depth. So we are ready to go. Let's go back to the laser. Okay, here we are. So again, we've already focused. We've already placed our object. We've got everything on the software set the way we want it. We can do a quick preview. Looks pretty good. Now I'm going to take this off of the tripod so we can get a better look at the actual engraving. There we go. Let's fire away. Now again, I told you I like to go pretty slow with wood, but that beautiful black engraving is exactly why that could be tough to get with the CO2. I'm just starting to wrap around the other side now. Get a proper focus. With wood, you really can go a lot further on the diameter, which is very easy to engrave with the UV laser. Just a little bit of text left, and we're done. There we go. That's it. You can see we got that wrapped down. A little tough to focus, which is going to be a lot more fun to deal with when we do glass. You'll find out glass can be really tricky to try and video and engrave at the same time. Now here's what I'm talking about with that those projection modes. You can see that the circle is actually quite a bit distorted when you're looking at it from the side. But if we look at it directly straight on, we have a perfect circle. So that's really just what that projection mode is doing. Again, play around with it. So there we go. This dowel I just bought from Home Depot. Actually, it was in the trim section, so I was able to just cut off a couple of feet. It only cost me a couple of bucks. And I'm not going to lie, engraving these dowels is a whole lot of fun. Here's another engraving that I've done on it, and that was, you know, you can really show off the detail that UV laser can get. And it's the exact same process, same settings, same everything, just a different graphic. So there we are. Congratulations. That may or may not be your first 3D engraving. If it is, good job. You're probably having a ton of fun right now. So let's move on to the real challenge. Glass can be tricky. It can be very tricky, and all of the things we've learned so far, we really need to take into account. Now, like I said, I'm going to be using this exact same jig for this glass. We're going to be doing a little bit different setup in the software, just a few extra steps, but we're still going to use cylinder. Again, having your jig centered is critical. If you're using a proper cylinder, ensuring that this top is level is also critical. Now, I know that this is a cylindrical cup, and I know the height of these two standoffs are equal, so I know that this is level. Now, being level is only pertinent if this is a cylinder. If you have a tapered cup that has a smaller diameter at the bottom, we don't want that top level. We want to make sure the cup is straight. And there are many different ways to do that. You're going to have to find your own way. I find using my my grip rotary is a great way to keep things straight for tapered cups when doing glass. I don't actually use the rotary, I just use it to hold the glass. But for cylinders, this works great. Now I'll quickly pop this back into the tripod here. We're going to do the, sorry for my fat fingers. We're going to do the exact same thing. We're going to set our focus height, again with our focal stick. Now, actually, I'm going to double check this because this is not looking like a true cylinder. It is not. There is quite a taper to that. So I'm going to reset. I'm going to set up with the grip rotary there. And we'll come right back. Okay, we're back. So we've reset using our grip rotary. One thing I'd like to mention is that I have the head of my laser squared to this table. So what that means is that I can use my engineer square to ensure that the XY table is square to the table itself. And then I can also make sure that the rotary is square to the XY table. That's going to keep everything straight in both our X and Y directions. Now, I know that this rotary is already centered in our X axis, but we do need to center the glass in our Y axis yet. So I just put a quick piece of tape onto the cup and mark its center line, and we're just going to move the XY table until our alignment cross lines up with that mark. So there we go. Our glass is centered in our X direction, it's centered in the Y direction, and let's remove this from the tripod again. This top edge surface is not level. The center line of the glass, better. The central axis of this glass, you can imagine going through the very bottom all the way through. This central axis is parallel to the table. That is the important thing with the UV laser. That's how our model is going to be set up. If this top surface was level, we also have to figure out how to rotate the model in our software to reflect that. That's a tricky process. I know this rotary is set up with a face square, which means that I know this central axis is also parallel to the table and will match our model in the software. And again, we'll double check our focus to the highest edge, which will be at the top. There we go. Remove this piece of tape. All right, let's head back to the software and get this set up. All right, guys, moving forward with our rocks glass engraving. So again, I've got a fresh file in Landmark. And the first thing we're going to do is create our cone. As I said, that glass did turn out to be tapered. Not by much, but it was tapered. And if you, again, with the UV lasers, we have a very, very, very tight focal depth. And even though our top diameter and our bottom diameter are only 3 millimeters difference, that is enough that your engraving will fail. So take your time, make that proper cone, because that 3 millimeters, which is only a millimeter and a half in radius, it will make a difference. Like I said, we're starting a cone here. Now I have my diameters, but we need radiuses, and as you know, your radius is half of your diameter. So we have a top diameter of 78. Divided by 2 is a 39 millimeter radius for the top. The bottom we have a 75 millimeter diameter. Divided by 2 is 37.5. And we have a height of 93. We'll hit OK. There we go. We have our cone. Now again, same as before, we need to move this top edge right up here, which will be our highest point, up to our 120 millimeter working space. So we will move it again. And you can go back to your cone here just to reference your heights and radiuses here. So we have a top radius of 39. So again, onto our calculator, we'll do 120 minus 39. That means we need to move this object up by 81 millimeters in the Z height. So again, into the Z. I've already forgot what that was because I have the memory of a goldfish. Sorry about that. Top radius of 39. 81. Let's remember that this time. We're going to move that up by 81 millimeters relative. Okay. Again, you can do a side or back view to double check that the very top edge of your model is going to be at 120. So we're good to go. Our model is set. So again, we'll import our HowTN logo. And again, I like to always move it up to 120 so I can see what I'm doing. Now for this, we said we had a top diameter of 78. Let's target 70% for our width. So we'll multiply that by 0.7. That gives us a 54.6 millimeter width of the graphic that I'd like to do. So we'll just call that 54. We'll resize that in the X direction proportionally. We'll hit apply. Now this rocks glass has a very thick glass bottom, which is somewhere around here. We could actually measure it, but I'm not going to. I am just going to, what I'm saying is that it looks a little funny if you engrave over that glass bottom, that thick bottom. So let's just move it up a little bit. I think that'll look quite nice there. Apply, and we'll move on to our hatch settings. Glass, I like to use a bidirectional. And this I actually do like to do an outline, and I like to outline it first. Sometimes I find it just gets the laser firing a little quicker, and sometimes you'll get a bit of a lighter engraving on your first passes, so an outline seems to help with that. Again, all the optimization settings on. I also like to use a 45-degree angle for glass because we're still going to be moving quite slow. Use a 0.025 millimeter line distance and a single pass. So we'll hit apply on that. Let's quickly move into our parameters again. For glass on a single pass, I like to run a 350 millimeters per second speed with a 45 frequency and pretty close to full power, 95. Again, I am using inverted power pulse width modulation, so 95 is almost full power for me. We'll hit apply on that. Now again, we want to move this graphic back down to 0. And then because it is a circular logo, I like to use the straight projection. And those lines always look a little funny. This is just one of those oddities of Landmark. It kind of just is what it is. Sometimes things can look a little funny, but once you get to the engraving, it looks just fine. So again, a quick little inventory. We've created our cone, our tapered glass. We've moved that up in the Z height. We've set our hatch and our engraving parameters the way we would like, and we've projected that graphic onto the model, which again has some strange lines, but we don't need to worry about that. Okay, back over to the laser. Let's fire this one. Okay, so we're back at the laser. We had a little bit of problems on the last engrave. I'm not gonna lie. I know I was playing around with the 64 and 32-bit software and some of my calibration got thrown out, so I have to make some few adjustments here. I did slow it down a little bit. And I do see there's some inconsistencies in the glass in this area, so I just decided that I'm going to run a crosshatch just on the test. Other than that, everything else is the same. Setup is the same. The alignment is the same. The projection on the software is the same. So we'll run this. Here we go. Okay, there we have it. Nice little Hautien rocks glass with a nice frosty engraving there. So again, on glass, things can be tricky. Take your time, make sure everything is square, straight, aligned, focused, level, that your model is correct and accurate in the software. And don't get frustrated, because it does take some time to get to the knack of it. So that's it. I hope you enjoyed the video. Hopefully you learned some stuff. And if this is the first time you've used a Feeltek Hautien 3D UV laser, congratulations. One other thing I'd like to say is that if you are struggling, there's a lot of really knowledgeable guys and gals in the community. We spend a lot of money on these lasers, so don't hesitate to hire somebody to give you a bit of training. I believe the rates are all pretty reasonable, and that can really kickstart a lot of things for you too. And that's about it. So thanks again for watching. Hope you enjoyed, and happy laser.